for the system of equations will be the graphing method. The good thing about the graphing method, you all already know how to graph. So a system just simply means you're graphing more than one equation at a time. So instead of just having one graph on your coordinate plane, as you can see here, you'll have two. Now, we basically deal with the system of two, but technically, by definition, you can have more than two. Okay, but for Algebra 1 purposes, we just do two. So here it shows you that when you're asked for a solution to a system, it basically means where the two lines would intersect. So like here, you would just simply read the coordinate. Okay, so when we do problems, we'll be able to read what that coordinate is, and that will be the solution to the system. This system doesn't have a solution because the lines do not intersect. So you only have a solution when the lines intersect one another. So this would be considered no solution. This one has infinitely many solutions because it's a line over top of a line. Okay, so there are two lines here, but it looks like one because they are the same line, which means they are intersecting at every single point. And so that's why it says infinitely many solutions. So coinciding lines means, they're just overlapping one another. They're the exact same line. Okay, so we're just going to graph it. Like I said, this is it'll kind of help us reinforce some graphing here. So the first one is a vertical line. So you just simply go here where x equals to -3, and you just draw a vertical line. Okay, same thing for the second one. It's already in slope-intercept form. So you start at -1. Okay, now I'm going to go up 5, and then I'm going to go to the left 3. So I can already see where this is going to intersect. And this is where, guys, you can't just do sketches. Your graphs need to be very accurate, okay, because you have to make sure you're reading the correct point where the lines are intersecting. So the solution to this particular system would be -3 positive what? And that's it. That's all you do. You just really are writing down, if the lines intersect, you're just simply writing the coordinate where they intersect. And that would be the solution to the system. Okay. All right, let's look at number 2. Same thing. We're just going to graph them. So this will be at +4. This time I'm going to go down 1 and then over to the right 4. Okay. And then I'm going to go ahead and graph the other one before I connect them. I'll start at -4. And then 1, 2, 3, 4, 5, 6, 7. And then over 4. So you can see that those two overlap right there. So now I'll go ahead and connect my first one together. And the second one. And then you just simply read the coordinates where they overlap, and this coordinate would be what? 4 and what? 3. And that's it. Okay. All right, let's move on to this one. Now, I already know that these lines are parallel. How do I know that? Because they have the same slope. Okay. You still graph it. Okay, I know I'm going to have no solution, but you still represent the graph. So -1, and then I'm going to go up 3, and then to the left 4. And if you wanted to make more points, you definitely can. I'm just going to do 2. And then the other one would be -2. So I'm going to go down 3 and then to the right 4. This is going to be pretty tight. Let me see if I already have mine graphed over here. All right, so here's my graph. All right, because it's pretty close together. Okay. All right, and now for the next one, we have to actually solve this one. These are not in slope-intercept form. So in order to graph, you got to put it in slope-intercept form. So let's go ahead and do that. Okay, and I have mine already up here. Let me erase this. So once you solve for y, let's see what we're going to have. We're going to have y equals 2x minus 3 and y equals 2x minus 3. So you can see that they're going to end up being the same equation. So it just will simply look like one line. Okay, that's it. Okay. All right, so just make sure you have written in infinitely many for that one, and then this one right here, make sure you write no solution. Okay. All right, we're going to move on to linear inequalities. Right, so here are our linear inequalities. So remember when we did inequalities with on a number line, and we either had a closed dot or open dot based on if it was an equal sign or not. So now that you're going to be graphing these inequalities on a coordinate plane, and I'm sure some of you are familiar with shading. Here it says if it's a less than symbol, whether it's less equal or just less, you're going to be shading below the line. Now, the difference between these is one line is solid and one line is dashed. Can you tell me why? Yes. So if it has an equal sign, it's a solid line. If it doesn't have the equal sign under it, then you make a dashed line. Now, so what does that mean in terms of the problem? It simply means all of these points that are along the solid line would be a solution to the inequality. All of these that are along the dashed line, those coordinates would not be a solution to the inequality problem. Okay. Same thing over here. If it's greater than, you're shading above. Okay. But if it has the solid equal sign under it, you make the line solid. That's the only thing that we're adding. Okay. So let's move on. So you do have to be careful because I know we automatically just like to make a solid line because we've been graphing linear equations with the equal sign. But now you have to really pay attention to the inequality symbol. So go ahead and graph. My graph is already over here in blue. So go ahead and start at -1 and then do your slope to get your graph. All right. Now, once you have your graph and this is greater than, that means I'm going to be shading above or below. All right, so I'm going to be shading above. All right, so now you can just make lines like this. I'm okay with that. All right, you don't need to really like shade and use all your pencil up. Okay, lines are fine. Okay, if you just want to make straight lines, okay, this is above the line. You just make a few lines going that way. So this one, the answer on this foldable is incorrect. This should actually be a dashed line because there is no equal sign. All right, so thank you. So I'm just gonna make it in red. Okay, so make it a dashed line. Make sure yours is a dash. And you just leave spaces in between. Okay. All right, number 2. Okay, now this one is correct. It should be a solid line. So go ahead and graph it. Start at your -5 and then do your slope. Okay, this is also greater So we're going to be shading above the line. And again, if you just want to make lines with your pencil, okay, like this is fine. Okay. Now, eventually we'll be making, we'll be having two of these on a coordinate plane, so then it will become a system. But today I'm only going to have you do just the single inequality. Okay, but eventually we will work towards making sure that we have a system. All right, number 3. Okay, so again, it's a solid line because of the equal sign there. And then since this is less than, we'll be shading below the line. Right. And then number 4. Okay, this should be a dashed line, so I'm just going to write over top of it. And which way do I shade for this one? Since it's less than. Above or below? Below. Okay. So your homework, just follow your calendar for your homework. So, and it's really, like you said, a pretty easy assignment because of the graphing and just adding the shadings. Okay, let's do 5. Since this is a vertical line, there is no above and below, there's left and right. Okay, so of course to the right would be greater, to the left would be less than. So if this says less than, then you're just shading the vertical line to the left. And then, of course, for a horizontal line, and again, this is dashed. Because there's no equal sign. And it's greater, so you shade above.